And we are on to Module 2. Module 2 is all about solving systems, different kinds of systems. So the first thing here in 2.1, we're going to ask ourselves, what on earth does that word even mean? A system. A system like a stereo system or a solar system or a respiratory system or a circulatory system. What do all those have in common? Well, they are made up of many different things all together, existing together, and working together even. Now, in mathematics, it's exactly the same thing. We have a system of linear equations that you're looking at right there. I know that they're linear because they're both x to the first, and in fact, they're in y equals mx plus b form. So you actually learned in Algebra 1 all about these when you talked about y equals mx plus b, and you learned how to graph them, and you got really good at it, hopefully, because you're going to need that skill today because we're going to be graphing these. So a system of linear equations are two equations that exist together. Well, what do I mean by exist together? Well, here we have a graph, and this x-axis and y-axis, they refer to the same variables. This x is the same as that, and this y is the same as that. So they exist together. It's not that they're necessarily the same value at all times, but they are this in the same world. So that x, the first x is the same as the second. So just a quick rehash of how to graph this. So this one here, y equals mx plus b, your b value, that's your y-intercept. So you go down one, put a dot, and then you use the slope. Now the slope in this first one is up 3 over 1. You got to put that 1 in there, up 3 over 1. And make sure you start from down here. Okay, so you go up 3 over 1 to get your second dot. That would be right here. Notice I didn't start at the origin. And then you draw your nice straight line. Hopefully this, yeah, there we go. Now the other one, what you do is you're going to go up 4, put a dot, and then this slope is up 1 over 2. So I'm going to go up 1 over 2 from that first dot, and I get the second dot, and I draw my second line there. All right, so this is what we mean by a system of linear equations or linear functions. Now, a solution, those are called answers, right? You want to know how to find the answer. So you better listen up. A solution to a linear system is an ordered pair that works in both equations. So this is the numerical. How do you know that an answer is an answer? Well, you plug and chug it and you see if it works. Well, the same thing happens here with systems. So I'm going to plug 4 and 1 in. So I'm going to put 4 in right here. I'm working this one. 4 plus 2 times, and then y is 1. Does that question mark, does that equal 6? Does it work? Yeah, 4 plus, so yes, 4 plus 2 is 6, so yes. Now let's check the second equation. I'm going to put 4 in for x, and then 1 in for y. Does that question mark, does that equal 3? Yes. So since 4, 1 works in both equations, it is called the solution. So yes, it was the solution in this particular case. I think we have another example here. A solution is a linear system or an ordered pair that works in both equations. That's what we just said. So we're going to try another one. In fact, you might want to pause the video and just give this one a try all by yourself if you're feeling like you want to be involved in this process. So here we go. I'm going to set it up for success here because that's what I do. So in black, I've put everything that always stays the same, the 2, the 5, and the 8. And then in the parentheses, I'm going to put the x value, which is -1 from this ordered pair that's circled on the right side. And then a 2 in here. Now let's work that out carefully. 2 times -1 is -2 plus 10. Does that equal question mark 8? Does that work? Yep, so far so good. So that's awesome. So let's go back to our black color because I'm going to recopy this, but I'm going to put my input spots there with big fat parentheses waiting for a number. And minus 2y equals, oops, not a y. We don't want to put a y there. See, I just said big fat parenthesis equals 5. So now I'm going to put that -1 and put that 2 in there, and let's see if it works. -3 minus 4. Does that question mark equal 5? No. Now, when this happens, I always go back and just check my work to triple check that I did not make a goof here. And as far as I can tell, looks like I did it correctly, and no. So you know what? This is not the answer to this system. So now that we know how to check answers, we should probably, don't you think, know how to find answers? Yeah. So again, listen up, put your phone down, listen up. Here it is. It's really simple. The solution is a point that they have in common. Listen, ready? It's where the two lines hit. It's where the two lines hit on the graph. It's where they intersect. All right, so on the next screen here, we're going to do this problem right there. Y equals x minus 3 and y equals negative x minus 1. So we're going to use our y equals mx plus b skills. So in this first one, m is 1, so up 1 over 1, and b would be -3. So we go down 3, put a dot. Remember how easy this is? Down 3, put a dot. And then the slope is 1. So don't forget the over 1. So up 1 over 1. It's actually at a 45-degree angle. So I would encourage you to get as many dots as you can because you know what? One of those dots might be the answer. So the more dots you have, the easier it is to find the answer, in my humble opinion. Let's look at the next one. The slope is -1 over 1. Whenever it's just a number like that, that came from this, by the way, right here. All right, and then the b value is the other -1. So I got to go down 1, put a dot. Now, what do you do when the slope is negative? That's where you go down and to the right. Always go to the right if you want to be right. So put yourself on the line. There, I'm on the line. Down and to the right, down and to the right, down and to the right. And that gets you lots of dots. Boom, you see it? You see it? What it am I talking about? Where they hit. That is the answer to the system. So the answer, the solution, is the point 1 comma -2. Make sure you put the x where the x is and the y where the y is. That would be kind of silly if you had those reversed and then missed it. All right, so listen to my words. Ready? The graph was not the answer. The graph was a tool to find the solution. So we graphed the two linear functions so that we could find that point that they have in common. And we could even check our answer by plugging that in to the original question and finding out that it works. Now, I do want to also mention, you better darn well have some good, nice, neat graphs here. Otherwise, boy, it's going to be hard to figure out where they hit. I also want to scroll back to this first question here. When we practice graphing y equals mx plus b and we did 2 lines, I want you to notice that the answer to this was 2 comma 5, 2 comma 5. And we can plug and chug that in and actually check. The answer to the system is 2 comma 5. The graph was not the answer. Remember, the graph was simply a way to find the answer. So we have now gone over how to solve systems by graphing. And you probably did this in Algebra 1. You may not remember, but you did do this during a chapter on systems. So hopefully this felt like a little bit of review and you feel solid in section 2.1. All right, take care, guys, and good luck.